Hey guys, welcome back. In this video, I'm going to show you how to evaluate limits of piecewise functions. So this is a piecewise function. The way that we read it is if any of our values are less than this number, we're going to use this. And if any of our values are greater than this number, we're going to use this. So for example, if I asked you what the value of f of 0 was, then you would put it into the top equation. So most of you already know how to do this. If I asked you about f of 1, you would still put it in the top equation because that's less than 3. And you would get points, okay? So the most important thing about this right now is going to be that number 3, the number that's basically right here, okay? So because we know that this is continuous because this is a line and this is a line. So the lines are always going to work. But the problem is this broke up at 3. So let's evaluate what happens at 3. Well, when you put 3 into this equation, you get 2 times 3 minus 1. So that's 5. When you put 3 into this equation, you also get 5. So what basically happens is the limit as x approaches 3 from the left is going to be 5. And the limit as x approaches 3 from the right will be 5 as well. Because these two match, then the limit as x approaches 3 in general from both the left and the right is 5. If you want to figure out what f of 3 is, you go to the person that's equal. In this case, when you put 3 in there, you get 5. Now, some of you might say, well, why are you actually putting a 3 in there? Well, let's say less than 3 is not just 2. You have to understand that less than 3 is 2.9999. So if you put 2.999 in here and you times it by 2, what you're going to do is you're going to probably get like 5.9999 minus 1 is 4.9999, which is just about 5. So yes, I am putting 3 in there, but it's almost the same. You're getting a number so close to it. So the only thing we care about, again, is what happens at this point. Guys, because this number and this number and this number and this number, all 4 of those numbers match, this function here is continuous. In other words, when you draw this line, the only problem that I have is at 3. I'm going to call this 5. Once you get to 5, that line looks like this. We're going to close the circle because there's an equal sign, and then this line will pick it up. And so therefore it's continuous. Let's try another one. All you have to do is plug 3 in right away. 9 minus 4 is 5 again. Plug in 3 right away. 3 minus 3 is 0. So what does this mean? The limit as x approaches 3 from the left is less than, is 5. Left, less than. The limit as x approaches 3 from the right is 0. The limit as x approaches 3 just in general does not exist because in order for it to exist, these numbers need to match. And then f of 3 is what happens at the equal sign. Well, the equal sign says 0. So therefore, this is not continuous because these numbers do not match. 5 and 0 do not match. So this function is not continuous. To be continuous, the following 4 must match. The limit from the left must match the limit from the right, which then will set the actual limit at the number, and then f of the number. All 4 of those numbers have to match. We're going to try 2 more questions, and then we're done with this video. Ready? What is the limit as x approaches 4 from the left? I must use the less than sign. If I were you, I would just automatically substitute this in, and then this here is going to be 1 because there's nothing to substitute in, so boom. 4 from the left says less than 4, so that's 1 from up here. 4 from the right says greater than 4, so that's this person here, that's also 1. Because these two numbers match, the limit is 1. What happens at f of 4 is the equal sign. So this is the equal sign at 4, 1. Since all 4 of these numbers match, the function is continuous. Okay? Here's our final example. What is 0 from the left? Let's use less than. Okay? So 0 from the left is -3. 0 from the right, let's use greater than. Plug in 0, 0. Because these do not match, you put does not exist. And actually, this is undefined because there's no equal sign under either one of these. So that's how we do it. Typically for f of something, we say undefined, but does not exist also can work. Okay, so that's how we do limits of piecewise functions.